What's up, guys? Welcome back to LeetCode Path Pro. Um, did some problems already today. That one a few days ago. So I'm just gonna go over them real quick. Um, yeah. Oh, this is really ugly. Sorry, I'm tired. Okay. So yeah. Firstly, this guy. Is that a annoying way to look at it? Okay, so it's 3,005. You guys remember this is contest, weekly contest 380. Just randomly picked, and I happen to have done this one. So, but it was cool to do it again. So yeah, so I've gotten better. So you're given an array nums consisting of positive integers, return total frequency of no elements nums such that those elements all have the max frequency. So you just count the frequencies of each integer, and then find, whatever that max count is, and then yeah, get the counts of all those. So yeah, so that's how I did it. Used a counter, sorted it, found the max count of our counted list. If it doesn't equal, we're breaking, otherwise we're adding it. Yeah. Yeah, pretty same approach here. Just using some fancier tools here. Okay, here we go. Find. Why is it not show the? Find beautiful indices in the given array. So I'm not gonna talk about the description. It's a little confusing. Basically, you want to find a substring that equals A, where there's a substring that equals B, and the starting indices of both these characters are less than, k distance away. You just find however many A indices there are. So here's how I did it. Found all the A spots where there's a substring. Found all the B spots where there's a B substring. That's the starting index. Got the length of A, length of B, result list. So that's just filling the A spots and B spots lists. And then we loop through everything in A spots. And then we do a binary search on the stuff in B spots. It's a little funky. Basically here we're just checking if that value, that mid that we found, if it's the difference between these two is less than k, we found a valid pair, we can break. Otherwise, if A spots of I, so like the spot, the index we're at is greater than B spots in the middle, and they're not less than k, then we know that we need to go to a higher indice of B spots. Otherwise, we'll go to a smaller indice of B spots. So, yeah, pretty cool. And you can also do brute force here, just double for loop, but this is faster. But that is accepted, and that does look like this. A little bit less code, but slower. Then I was sorting. You don't need to sort necessarily. Maybe I was using a set at that point. Yeah, you don't need to sort. Yeah. And then the last problem, just another easy. It was very easy. I don't even think my solution is optimal, but you give an array of integers nums of length n. The cost of the array is the value of its first element. For example, the cost of 1 to 3 is 1, while the cost of 3 for 1 is 3. You divide nums into 3 disjoint contiguous subarrays. Turn the minimum possible sum So if you think about it, you're always going to have to take this first value. But then you can take, any combination of the next two smallest values. So that's what you're doing, just finding the two smallest values. Yeah. So the result was 0. Right, because you have to take that first value. We have a heap min-vals, pushing everything on min-vals except for that first value. And then just 2 pops of that heap. Add those because it's a min heap, and then that's our result. So yeah, pretty straightforward. Yeah, those are the problems today. All right, thanks for watching. Have a good night. See you guys.